Hi, I'm John Hardwick. I'm the Managing Director of Intouch Monitoring. We've been producing production monitoring or MES systems for close to 30 years now, and I'm going to show you today, give you a quick overview of the system, how it works. Normally, I'd say if you've got any questions, feel free to butt in, but you're not going to do that. I'm running a demo of the system on my laptop, so I can show you quickly through some of the main areas and hopefully you'll find it interesting. Okay, so this is a default screen when we start the system up. It's what we call a mimic diagram, so it's a live dashboard of your factory. So we take a simple signal from each machine. That's just a single pulse once each cycle of the machine, and from that we know if the machine is running or if it's down. If it is running, we're monitoring the cycle time and counting the parts made. From that we can provide a live dashboard of what's actually going on in your factory. So we can see here in my example I've got a number of machines that are currently green, so they're running, some that are red or other colours which are currently stopped. Now, we know the machine has stopped because we stopped getting our signal from the machine, but we don't know why it stopped. So here I have a machine that's currently red that says alarm. This is my default stop code. So I can then interact with the system and select a specific downtime reason. So maybe we've got no material. This will then change this period of downtime to be no material. So at the end of the shift or week or month or whenever, you'll be able to analyse the downtime, see which were the biggest problems, the biggest problem machines, or what the worst downtime was, and so on. Now, just having this visibility of what's going on in your factory in real time gives all of our customers an immediate improvement in their machine utilisation. So you can see what's going on, you can respond to stops more quickly, and everybody in the business can see what's going on. With the system, there's no limit to how many users can use it. So you can install the software on as many devices as you like, including large screens, large displays around your factory, again, so that everybody has got visibility of what's going on. Now, as soon as the machine restarts after a period of downtime, it will automatically go back into green and running. So the operator does not have to interact with the system to say the machine stopped now and the machine has now started. That is fully automatic. So it gives a very accurate measurement of your utilisation. The dashboards are very configurable. So on this example, I've obviously got the machine name, I've got a description of the part that's running, I've got the standard cycle, actual cycle, job number and job time remaining. So this is quite configurable. This is just an example. If I click on another example here, it's exactly the same. I have my machines with their current status displayed by colour, but laid out in a tabular format so we can get more information about what's going on each machine. So in this example we've got a description of the job again, cavities, cycle time, and then I have my OEE data for each machine for this shift, so my performance, availability, quality and OEE. And so that is just another example dashboard. If I double click on a machine, it will drill down and give more information about what's actually happening. So again, we've got some job information for this machine, descriptions, order quantity, the balance left to produce, due date. On the right hand side of the screen we've got information for the current shift and for the job to date, good parts, scrap parts, runtime, downtime and so on. Again, this is a configurable screen, so different fields can be added to this screen depending on what information is most important to you. Further down we've got here a job schedule, so I've only got one part planned onto this machine, or one job which is currently running. Beneath here we have a cycle profile, so this is listing each individual cycle as it's being monitored, and building a history of the cycle, so you can actually see that moving along. We can see here there was a job change, and so they've changed from one job to another. And I can zoom in and out, go back and look at history here. Again, I've got my performance information, my OEE information for this job. I can see my actual performance rate at the moment is 113%, so I'm running faster than standard. So maybe that's something I'd like to look at to see whether or not I can produce good parts at that speed, and then perhaps reassess my standards. At the bottom here, we have what we call the shift profile. So this runs from 11 AM and through till 7 PM. So that's the shift that I have set up. And I can see when the machine ran, when it stopped. So I can see here, if I click on this period, that it stopped at 2 minutes past 11, restarted again at 11:28. But it was down to alarm, so no downtime reason was entered for that period. Now I can go and actually change that after the event. So I can come in here and we say, okay, we had a mould fault. And so now let's change that period of downtime to mould fault. So again, when analysing the data in the future, it gives you all of the real information, and it gives you the ability to change things if information is entered incorrectly. So often, if our customers have an HMI or a tablet or PC at each machine, the machine will just give information, or that display will only show information about the machine that it's connected to. So it makes it very easy for the operator to actually interact with the system. So we saw entering downtime codes. We can also enter rejects. So if I press the scrap button here, it then gives me a list of my reject options. So if I enter 5 parts for flash, we can see here now I've just entered 5 scrap parts. So that's had an effect on my quality rate. And so you can see this is all happening in real time. So as the operators are interacting with the system, you're constantly getting real-time feedback from what's going on in your factory. In terms of the stop and scrap codes, they're completely configurable. So that's down to our customers, and then you can have as many different codes as you like. So there's no limit. So if we close this, go back to our main screen, we have some other buttons at the top here with some other options. So things like changeovers, monitoring tool changes. We treat tool changes a little differently to other scrap codes, other downtime codes. So if a machine stops, normally as soon as it starts again, then the system will register that as running. Now sometimes when you're actually performing a tool change or a changeover, you want that period to be monitored as changeover, so essentially lost time. But it's possible that you may be cycling the machine. So you may be, if your setters are actually setting the machine, they may cycle the machine a few times and then stop it and make further adjustments. But all of that period we want to monitor as downtime for the tool change or the changeover. And so we treat changeovers a little differently. When I double clicked on the machine, we saw that it drilled down to show us information about what's currently happening on that machine, and it has information about the job. So it is pulling that information from our job schedule. So if I click on our schedule view, so this is a fairly typical Gantt chart. Again, I have my machines listed down the side. The green machines are currently running, and the red and other colours are stopped. So that's the current status of the machine. And against each machine, each of these bars is representing a work order or production order. And so you can see with this view, you can easily see if you've got any spare capacity, if you've got any bottlenecks. The green jobs are going to be produced on time based on their due date, whereas the red jobs are going to be late based on their due date. So I have one here, the job that says MS20 red lid. If I pull this forward, and when it is my next job on the machine, you can see it turns green. So in this position, we're going to be producing this on time, whereas out here, it's red, it's going to be late. And so that also demonstrates it's a very simple drag and drop scheduling board. So you can see I can easily move jobs around very quickly and very easily. And as soon as I've made that change, anybody in the business sees that happen. So it's a real-time planning board. The greyed out period that you can see in the middle, this is my unworked shifts. So this is a weekend. If I look at my planner here, we can see that these are my individual shifts and this is the weekend. So I can then go in and quickly say, okay, actually on these machines, I want to run overtime at the weekend. And we will then see on the Gantt chart that that has been reflected, adjusted the jobs accordingly. We can see that now Saturday for these 3 machines is no longer greyed out. So if I go back in and I'll just put those shifts back into not worked, and it will have again extended the jobs to give you a more realistic view of what you can expect to achieve. At the bottom here we have a table showing us essentially the same information, but in a tabular view you can obviously get a lot more information about each job. And again, the fields that are displayed are very configurable. In terms of getting the production orders or the works orders into the system, most of our customers will import these orders directly from their ERP or from another business system or from Excel. So it's a very simple process of importing all of the jobs straight into the system so that you're not having to double enter. If you don't currently have an electronic schedule of work, then we can also set up all of your parts within the system and add jobs manually. It's all a very simple process. The blue bar at the beginning of each job is showing us setup time. So I've got a standard setup time for all of my jobs, but that's just again extending the job to give you a more realistic expectation of your plan. We can also plan by start date. So if I know that I've got a tool that's coming in on a particular day, I can plan that in there. I can then say, okay, I've got some spare capacity, which I can fill up with other work. And so again, it's a very, very quick and easy to use planning board. And because we're connected to the machines, this whole plan is moving in real time. So as the machines are monitoring, all of the jobs are moving. So if we have a machine that all of the jobs are currently green, so they're going to be produced on time. If that machine breaks down, it will go red, obviously, but it starts pushing the work back, and at any moment in time, one of the jobs that's planned onto that machine could turn red, so highlighting to you that you've got a potential problem. So that's the scheduling. The real-time monitoring is really what's happening now. The scheduling is what we're planning to do. So the third main area of the system is the reporting. So if I click on my Messy tab here, this brings up our reporting module. I have a selection panel on the right where I can select which machines I want to report on, or I can also select all machines or work groups of machines if you have those set up. At the bottom here, I can then select a period to report on. So common reporting periods like the current shift or yesterday or last week, we have radio buttons set up, but you can also select exactly what period you wish to report on with the calendar tools. So I'm going to go back a few months to when I have some customer data in the system. So I've selected a week here. If I now click OK, that will pull in that week's worth of data into our report module. So this is a graphical overview. I've got an OEE staircase at the top here, which tells me that for all of the machines that I've selected, there's a total time of just under 2,300 hours. So that's calendar hours. Of that, my available time is 1,600 hours, planned downtime 693 hours. And so this will mostly be my weekend. So I've set all of the weekend or the non-work shift as planned downtime for the purpose of OEE. So of my 1,600 hours of available time, I actually only ran the machines for just under 460 hours, giving me unplanned downtime of 1,146 hours. So, and then as we work up the staircase, so of my 458 hours, my standard time produced is 421 hours. And so this small blue crescent on the end here, this is time lost to running slowly. So if we look at our performance gauge here, we was running on average an 81.4% performance for this period. And so we can see here that's resulted in essentially some lost time due to running slowly. And then at the top here we've got our standard time earned, 373 hours. And again, the time that we've lost on the end here from our standard time produced is time lost to making rejects, which is reflected here in our quality rate. So we have a quality rate of 81.2%, which has resulted ultimately in us earning just 373 hours of good product from our available time of 1,605 hours. And so it's a rather poor 18.9% OEE. Elsewhere, we've got Paretos for the downtime, scrap, and also for the machine. So as we're analysing a number of machines here, we've sort of got a Pareto showing us our best machine is machine 7. If I click on machine 7, it then changes the focus of the rest of the screen to just look at machine 7. So we can see here, again, the calendar hours, for the period that I've selected there, 176 hours, and so on. So the OEE was 50%. I can select other machines and see which machines were performing well, which machines were performing badly, and start to actually look at the downtime rejects. Why were they performing badly? Using that information to then make improvements, make decisions about what you're going to do within the factory to actually improve the performance. We've also got the same information by shift, and so I can drill down by shift. I can drill down shift and machine and so on. So it's quite a nice, flexible way of looking at the data and drilling down and seeing where the biggest problems were. If I click on the OEE report here, this is still got the same information that we selected a few moments ago. And perhaps what I'll do, I'll just change. We've now pulled in a week's worth of data exactly, so 168 hours per machine. And again, we've just got our OEE information here for each machine, runtime, downtime, availability, performance, quality, and so on. At the top of the screen, I can change the filtering of this information. So if I click shift, it's filtering by shift. So I have my morning, afternoon, and night shift, so I can compare my shifts directly. I can also filter by job or by part, by zone or area of the factory, or I can look at it by day. So it's breaking it down by day. Any of these I can print out or export. So if I click the export button here, that brings up an Excel window. So it's exactly the same information, but just dropped into Excel. So you can then analyse the data yourself, combine it with other information, produce your own graphs and so on. I'll just close that. Some other options, we have a downtime report. So this is exactly the same. So at the moment, we've still got the same selection of my 1 week in October, 168 hours on each machine, but I've got a breakdown of all of the time, so the run time and then all of my different downtime reasons that are set up in this system. And again, I can look at that by shift, job, part, and so on, and also export it. So obviously, when you have many stop reasons like this isn't very friendly just to print out as it is, but the ability to export it into Excel, everybody, or most people are very familiar with Excel, and it gives you the ability to analyse that information yourself, produce your own reports. And I have the same here for scrap. So that's a quick overview of the reporting. As I said, much of the system is very configurable. Things like control buttons, depending on how we operate the system, we can work with our customers to configure it to fit into their environment as closely as possible. So rather than saying this is exactly how you have to work, we can work with our customers to configure it to their environment, allows them to get the most out of the system with as little effort as possible.